So we're looking at this foundation problem here where we've got to find the settlement underneath the foundation. I'm going to use the De Beer-Martin method to work out what is the settlement under this foundation here. And one of the first things we're told when we look at the De Beer method is that it's quite a good idea to divide the foundation up into layers. Okay, and partly because what happens under a foundation, if we were to look at this particular foundation here that we've got in the ground, we would see that the settlement would be maximum underneath but would decrease as we were going down. And so it's very useful, or very often done, that we actually divide the foundation up into layers. So the method talks about ideally we split a deep deposit up into layers, and we consider a depth of 4b, where b is the width of this foundation. So in our case, b is 2 meters. B is 2 meters. So really, we should be looking at, not drawn this to scale, but look at layers of 2 meters. So you can imagine that we're basically going to be going down to 4 meters. Sorry, 4 lots of 2 meters, which is 8 meters, but underneath this foundation. So this is our formation level, and we're going down in 2 meter increments. 2, 2, 2, 2. And for each layer, we're going to look at how much settlement do we have in each of these layers. So this is row the settlement in each of these. So this will be for settlement for layer 1, 2, 3 and 4. And basically we do a little mini calculation for each one of them, and this is where we're going to look at how Smith has certainly solved this problem using a table. And so I'm going to go on to this table that he's produced, which I'm going to just talk you through how this whole thing works. Okay, and hopefully you'll sort of get an appreciation of just what is going on here. So we can see the end. We can see the answer. Okay, 40 millimeters, or 36.2 millimeters to be precise. But it's how do we get to here from the beginning of the problem? Okay, so just talking it through a little bit, we can see that there's these 4 layers, each of one of which is 2 meters thick. So hopefully you can see that. And we're trying to work out what is the P01, which was the effective overburden pressure at that particular point. So if we've got a 2 meter thick layer and we're 1 meter down, what is the effective overburden at that point? And the effective overburden is due to the weight of the soil. Okay, and the weight of the soil, we're told, is 18. However, we are 1 meter below the water table, and so really the effective overburden is the 18 minus the water pressure. So you can see for the rest of these calculations, we're using it's much more expedient to write the buoyant